All right, so basically, we'll go over any questions. If it looks like there's no questions, we'll move on to the next problem. However, one like this, I think it's probably a good idea to go ahead and go over it. All right, so this is problem 9, and we have angle A is 40x minus 20 degrees. Angle B is 36 minus 2x. And angle C is 8 plus x. All right, and here's a picture of our triangle, A, B, and C. Okay, so all right, so here's our problem. So they give you the angles, right? And the problem asks for find the measure of each unknown angle. Okay, sometimes they only ask for one. This one asks for all of them. Okay, so we kind of went over this briefly at the end of the last class, but we're going to go ahead and go in more in detail. Okay, so what relationship do we have with these three angles and a triangle? Yeah, they all add up to 180, right? So angle A plus angle B plus angle C, they all add up to 180 degrees. So we substitute our equations in for each angle. So angle A is 40x minus 20. And since they're all adding, I'm not going to put the parentheses. Next angle is 36 minus 2x. Angle C is 8 plus x, and they all add up to 180 degrees. Okay, now what do we do? Combine like terms, right. We've got 40x minus 2x, that's 38. 38 plus 1 is 39x. And you got a minus 20 and a plus 36. So that'll be a plus 16. 16 plus 8 is plus 24. Equals to 180. All right. Now what? Yeah, we solve for x, right? So what do we do with this 24? Yeah, minus 24, minus 24. And we get 39x equals to, and then 180, right? Minus 24, so that'll be 6. 7 minus 2 is 5. So we get 156. All right? And then we divide by 39. Divide by 39. Okay? And so we get x equals to, let's see if I can probably should have that line. So we get x equal to 4. Thank you. We get x equal to 4. But that's not our answer, right? What do we have to do now? Yeah, substitute them back into each one. So 40 times 4 is 16. 40 times 4 is 160. 160 minus 20 is going to be 140, right? So that's 140 degrees. And so the next one is going to be 36 minus 2 times 4 is 8. So 36 minus 8 is 28. And so we've got 8. So let's see, is that 8? So we got, yeah. And so now this will be 8 plus 4 is 12 degrees. Okay, so now if we take each one of these, 140 plus 28 plus 12, they should all add up to what? 180, and they do, so it checks. Okay, so our answers here are 28 degrees, we can start with 12 degrees, 28 degrees, and 140 degrees. And so all three of those together is the answer. Okay, questions with number 9. Okay, so let's take a look at problem 10. Find the measure of the exterior angle. So we've got angle X, Y, and Z. Which one of these would be the exterior angle? X is the exterior angle. That is correct. Okay, so we're going to go over this one too, because this one students tend to have some trouble with as well. All right, so our triangle, X, Y, and Z, and angle X is 198 minus 5n. Angle Y is 6n plus 32, and angle Z is n plus 10. Okay, so this is what we got. Now, what principle here can we apply to exterior and to, I'll give you a hint, to remote interior angles? Very good, that is correct. The exterior angle is equal to the two remote interior angles. So we could say that angle X equals to the sum of angle Y plus angle Z. Okay? So it helps to write this relationship down with the angles before you start. So angle X, that would be 198, right, minus 5n. 198 minus 5n. And so what are we going to put in here for angle Y?
6n plus 32.
Yeah, 6n plus 32 plus angle Z would be n plus 10. Okay? So now what do we do? Yeah, combine like terms on the right side. So we leave the left side, just let it ride for right now. 198 minus 5n, that's a 5 there, equals to, we've got 6n plus 1n is 7n, plus 32 plus 10 is 42. Questions there? Okay. Now, I've said in the past, it's easiest to try to keep what positive? Yeah, and you want to keep the variable positive, right? So do we want to apply plus 5n or subtract 7n to keep the n's positive. Yeah, plus 5n. So we apply plus 5n plus 5n. And I would recommend that you do this step because you're subtracting on the left side, but what are we doing on the right? We adding or subtracting there? 98. So 7n plus 5n is what? 12, right? 12n plus 42. Okay, now what do we do? Subtract. Yeah, what are we going to subtract? Yeah, we want to subtract 42 minus 42 because we want to isolate the n, right? We want to get the n by itself. So we're moving everything else over so that n is going to be by itself at the end. It's going to be isolated. So 8 minus 2 is 6. 9 minus 4 is 5. So we get 156 equal to 12n. And now what do we do with 12? Yeah, we divide 12. Divide 12. And so 156 divided by 12 is what? 13? Okay, so n equals 13. All right, so we only want what? We ask find the measure of the exterior angle. So which one of these are we going to substitute 13 back into? Angle X, right. So this will be 198 minus 5 times 13. Well, 5 times 3 is 15, right? And then carry the 1, 5, so that'd be 65. So 198 minus 65, right? That'll be 8 minus 5 is 3, and 9 minus 6 is 3, so that's 133 degrees. Questions there, and that's your answer. So you only had to find one angle this time, they just wanted the exterior one. Okay, questions there. Okay. Number 11, two triangles similar, find the unknown side length. We need to see that one. Yes, no? If nobody needs to see it, we'll move on. Speak up. No? Okay. We're good there. All right, number 12. Represent two legs of a right triangle. C represents a hypotenuse. Find the unknown side. Any questions with that one? With number 12, finding the unknown side of a right triangle. No. Okay. Find the area of a rectangle. Area of a rectangle. Do we need to see that one? It's just length times width, right? So this is A equals 8.7 and B equals 10.3. It didn't come out. It shows up on the you can barely see it on the slide, but it shows up better when you're looking at the document. Okay, and then here again, we want to find the area of a triangle. Questions with that? Okay, volume of a rectangular shaped box. Any questions with that? Do that one? Okay. Alrighty. So, number 15. So basically we've got height is 3 feet, and we've got length is 8 1/2, and the width is 7 1/3. Feet. Feet. Okay. All right. And let me see how they express the answer. Okay. So basically, you can, so we know that a cube, right, is length times width times height, right? So you can say here our volume of this cube, this marker's going on in, volume, length times width times the height. And so we can convert these to decimal, all right? So this would be 8.5, and 7 1/3, that's 7.3 repeating. So that would be 3 feet times 8.5 feet times 7.3 feet, and so we just multiply all these together, right, and we get 187 feet cubed, because it's feet times feet times feet. Okay? Questions there?
I thought the same was a box.
Let me see. Find the volume. Yeah. Yeah, so volume of cube, right, is length times width times height. Okay? So you're going to multiply length times width times height. So you're just multiplying all these together.
But isn't that one as cubed?
Yeah, so that'd be feet cubed. Oh, okay. Now that would be if you had a perfect square volume, like if all the sides were the same, right? Then it would be S cubed, right? But this one, they're not all the same. So with a perfect cube, right, they only give you one side because all the sides are the same, right? But here, it's a rectangular cube, so that all the sides are different. So you have to use length times width times height, okay? So you see the difference between the two? Now with a perfect cube, right, where length times width, and height are all the same, you could put side times side times side, right, which would be length times width times height, but it would still be the same as side cubed, okay? So that's why we just say side cube for that one. All righty? Thank you for asking that. That's a good question there. Okay. Use of properties of parallel lines. Assume that line M and N are parallel and cut by a transversal. Find the measures of angles A and B. Well, angles A and B, do we need to see 16 or are we okay there? Basically, angles A and B are what in relation to each other? They're equal, right? Alternate exterior angles are equal just like alternate interior angles are equal. Good. So you set their equations equal to each other and solve. All right. So nobody needs to see that one. All right. Number 17. These angles are what kind of angles in relation? Supplementary, right? So you do two angles and you do what with them? Add them and they equal what? Right? Anybody need to see that one? No, we're good? Okay. What about 18? Questions with 18. What kind of angles are these? Complementary angles, right? Because they add up to what? 90, good. And you get that perpendicular looking square box in there, meaning the two sides are what in relation to each other? They're perpendicular, right? They add up to 90 degrees. So the box means the sides are perpendicular. It doesn't necessarily mean that it's 90 degrees. It means 90 degrees. It means the sides are perpendicular. But perpendicular sides always are 90 degrees, right? Okay, find the area. Now here we have the area of a triangle again. Okay, area of a, what kind of figure is this? Trapezoid, very good. Any questions with the area of a trapezoid? Okay, sure. All right, area of a trapezoid. So I'll draw that out. And we've got 16 miles and 8 miles and 40 miles. So this could be the shape of, let's say, forest area. Maybe it's burning, okay? And the burnt area came out to be like a trapezoidal shape because it's in miles. So we want to figure out let's say we want to figure out what the total burnt area is. So we recognize that it's trapezoidal in shape. So the area of a trapezoid, we want to know what that equation is. So basically, if you don't remember it, think of a triangle, right? 1/2 height times the base. But with a trapezoid, how many bases we got? 2. We've got 2 bases. So this would be base 1 plus base 2, and that's in parentheses. So if you don't remember the area of a trapezoid, think of the area of a triangle and add another base to it, put parentheses in it. Okay? All right, so this will be 1/2. The height is always what in relation to the base? Perpendicular, right? So the height is going to be 16 miles. And then the 2 bases, we know that the 2 bases are always what in relation to each other? Parallel. They're always parallel. Very good. Excellent. So this would be 8 miles plus 40 miles. Okay, questions with that? All right, so now we're going to get 1/2 times 16 miles. 8 plus 40 is 48 miles, right? Now, here, if I can cancel when the numbers are small, I definitely want to do that. I cannot do it here because of the plus, but I can do it here. And so 2 can go into 16, right? Or 2 can go into 48, either one. But we'll put in 16, and that's 8. So now 8 miles, right? So now we have 8 miles times 48 miles. Okay, and so we end up with, what was that, 20, right? 48 times 8 times 8 is 64. 8 times 4 is 32, 38, 384. Miles times miles is miles what? Units. Like x times x is x squared, so miles times miles squared. Okay, good. And that's our answer. All right? Questions there? Area of a trapezoid. Okay. Circle. Area of a circle. Any questions with that? Okay. Well, with 21, Are we given diameter or radius here? Yeah, we're given diameter, right? But our area, so this is 6 centimeters. But area of a circle is in what? Area equals what? Pi times what? Radius squared. Well, we're given diameter, right? So we got a little bit of a problem here, right? Our diameter is 6 centimeters, but we need to figure out what our radius is before we can plug it into our equation, right? Because our equation requires radius, but we've got diameter. So, yeah, we divide by 2, right? Because diameter equals to 2 times the radius. So if we subdivide it by 2, right, we get 3 centimeters. So area equals to pi times 3 centimeters squared. And so that's going to be 9 pi centimeters squared, right, in terms of pi. But they probably want us to round that off in decimal, right? So we have to convert pi to what? Pi as a decimal is rounded off to what? 3.14 centimeters squared. And so we end up with 28.26. Well, 9 times 3, and you can check by 9 times 3 is 27, right? Since it's a little bit more, it's going to be a little bit more than 27, right? So that looks good. Questions there? All righty. Okay, total surface area. Questions with that? Basically, you find the area of each side and you add them all together. Do we need to see 22? Are we good? Yes? No? We good. We good? Okay. All right. We're good. Okay. Awesome. Okay. Find the surface area of a cylinder. Circular solid, unless otherwise specified. 3.14. All right. So questions with that? We good there? Just gotta make sure you get the formula. Okay, sphere. Questions with 24. Questions at all? Yes. Oh, 11. All right. Yeah, sure, we can do that. All right. So we've got 2 triangles, right? So these are known as what kind of triangles? Similar, right? They're not, the sides are different, right, from between one triangle and another. So they're not congruent, but they are similar, meaning they have the same angles but different. They have the same angles inside, right? But same shape but different lengths to the sides. Okay. So we can say, looking at these, we can say that 12 and 6 are similar sides. So if we can figure out the relationship between these two, then we can figure out the relationship between X and Y. So you look at the 2 sides that you have, right? So 12 So basically our unknown sides are x and y, right? So we're going to go small, triangle of the small over the triangle of the large. Okay, so that would be 6 over 12, right, is going to be what? What's 6 divided by 12? Is 1/2, right? So that means x is going to be 1/2 to 15 and y is going to be 1/2 to 21. Okay, so 15, so x is going to equal to 15 divided by 2, right? Which is going to be what? 7 point what? If 2 times 7 is 14, right, 7.5, right? So x is going to be 7.5, and the other one is going to be what? Well, what's 21? If 20 divided by 2 is 10, 21 divided by 2 is going to be 10 point what? 5, right. Okay, and those are the answers. Alrighty? Okay, any other questions? Okay, yeah.
No, I had something different. I thought I had problems.
You what?
I had something different. I thought I had problems.
Oh. Okay, so I wanted to go over the QEP essay next. Okay, so let's see. Okay, it's this one.